As you write more and more code, it becomes very important to organize that code into ways that are reusable. One of the ways to organize code like that is to use functions. A function is just a grouping of instructions, a bundle of instructions that's given a single name. And then any time that we want to execute that whole bundle of instructions, we just use the name and tell it to happen. The print function is one that you've already seen so far, and it's got some sequence of instructions that you don't need to know because you can just reference its name and say, I would like to print, and it will do whatever those instructions are. Here's another example of a function. It assigns some values to some variables, and then it prints one of those variables. And what it does in detail is really not quite as important as understanding the different pieces. Here we see the function name, which is var assign with an underscore between them. And it has a set of parentheses after it. We'll dig a little deeper into this parentheses piece later, but right now we just know that to call it, we would just give its name and those two parentheses, and it would execute the whole body of this function. In Python, to define a function, you have to use this special keyword def, D-E-F. Then you give the function name, then the parentheses, a colon, and following the colon, everything that is a part of the function gets indented. In Python, we use indentation in lots of different places. It's used to show that some portion of code is inside of another statement, like how these lines in here are all inside of the var assign function. And then this down here that's indented is called the function body. It is the sequence of instructions that the function will do when we execute that function. So you can see in this example, this is not the same as the function that I wrote before, because for these statements to be included in the function var assign, they would need to be indented. This is one of the things that in Python sometimes makes it more readable, especially for beginning programmers. Other languages require extra syntax to group and say where the function starts and ends. Python uses the indentation because it's a nice visual cue for where things go. This code shown here is actually invalid because the function has nothing inside of its body, because none of these are indented. So here we've gone back to those lines being indented, therefore they're in the body of the var assign function. Another way to talk about this is to say that everything that's inside the body of var assign is in its scope. And we're going to discover that there are lots of different ways that we can define chunks of things that have their own scope. But essentially, you can think of it as these variables getting created inside of the var assign function, and that they sort of stop existing once you get outside of the var assign function. And we will dig much, much deeper into this idea of scope later. But for now, just understand that these things exist inside, they stop existing outside. It's a suggestion that you use 4 white spaces for your indentation. Different programming environments will use either the tab character or a different number of spaces or things like that. But it's nice to have a standard, and so ours would be 4 white spaces when you're indenting things. Basically, when we define a function, we're teaching Python, or whatever programming language we're using, how to do a new thing. All of our code teaches the computer how to do new things, but here we've taught Python, here is a new thing called varassign. Here's how you do it. And then once we've taught it that, we can call or execute that function. And we're essentially asking Python, do the thing that I specified before. So if I teach Python how to make a peanut butter and jelly sandwich, then I can use that name of peanut butter and jelly sandwich, and it will be able to execute that sequence of steps and make the peanut butter and jelly sandwich, assuming that it has control of some robot in the actual world. But for here, this one is assigning these variables, adding 2 of them, and then printing the result. And so we can call that over and over again and get Python to do that same task lots of different times. The example we gave before is one nice way to do something over and over again that you might want to do repeatedly, but it wasn't very versatile. It assigned the exact same values every time and therefore would print out the exact same result each time. We can write a function to do a wider range of things if we give it inputs. Those inputs in the context of a function are often called parameters. And those parameters are things that we can pass in or that we can hand to the function when we call it, and then it does whatever task we've specified using that value. The names for the parameters go in the parentheses of the function definition. And I can define 1 or more parameters here, separating them by commas. So here, I've named this parameter x, and when I provide 4 later while I'm calling it, then 4 will be the value that gets used for x there. So that print double would take 4 as x, it would do 2 times 4, store that as print val, and then print out the number 4 here. But when I call it again later, I give it a different value for x. So now I'm giving it 20, and it would do 2 times 20, and therefore it would print out 40 here. I'm sorry, I think I may have said it was printing 4 before, but it would print 2 times 4, which is 8 as the first call there. So it's going to use whatever value I give it. This now means that I can teach Python how to do something by writing it one time, and I can then do, in this case, an infinite number of things with that, because there's an infinite number of numbers that I could pass in as x. I can use this an infinite number of ways just by writing 3 lines of code to define what print double means. And so this is the kind of thing that can really help you to organize code. If you find that there's a pattern that you're repeating over and over again in your code, for example, get the user's name and create them an email address from it, rather than copying and pasting that code over and over in lots of places, which is one thing that many programmers do when they encounter that kind of situation, rather than copying or repeating that code, you could write a function. And as long as you find the parts that might need to change from time to time, for example, the person's name, then you define those as parameters, then you can call that function in lots of different places, potentially with different parameter values, and reduce the amount of code. If you imagine this piece here, I would have to have written the print val equals 2 times something and print val in both of these places. So what I've done in 2 calls to the function would have required at least 4 lines of code if I were copying and pasting. And if I had to print double 100 times, then I would need 200 lines of code if I've copied and pasted just those 2 lines over and over. You're also much more likely to introduce errors into your program if you are copying and pasting or if you are repeating things over and over in your code. If we write print double and we ensure that it works properly, which we can do by testing it out, which you'll get to see more in your labs and in some of our future discussions. If we make sure that print double does its job right, then I know that I don't have errors in places where I use it. But if I'm copying and pasting, I might make an error in how I copy and paste. If I'm repeating code and then I find an error in it, I have to fix that error in all of the places I repeated that code. So functions can be a beautiful way to solidify some behavior, work on it until we know it's right, and then avoid repeating code all over the place in our programs. And we'll see other ways later to avoid repeating code. So I want to revisit the idea of a variable because we've sort of expanded it here. We have regular variables where we say something like x equals 17. And then we have parameters where we give a name for that parameter in the declaration of a function, but we don't know what its value is going to be yet. And this is something that beginning programmers often find very, very challenging. What is num right now in this function called myfunc here? I don't know. I might make some assumptions about what users are going to provide to me or what data I'm going to have when I call to myfunc. For example, I might assume that it's a positive number. I might assume, for instance, that denom, the denominator, is not 0. So I'm certainly allowed to make some assumptions about those, though once we send code out to users, they will almost always break our assumptions about those. But I can make some assumptions about what kinds of values might come in here, but I don't know if num is 16 and denom is 2 or anything like that. I'm not going to know until the function is called. When the function is called, it's sort of like saying num equals 16 and denom equals 2, or whatever values are given when I call that function. And this is a little harder to follow than our explicit assignments to variables before. When I see x equals 17, I can look and see that x will be 17. And x can have one value at a time. Whereas with my function calls, they're going to get values based on whatever was passed into them when they're called. I want to remind us of this print function that we've seen a couple of times and kind of glanced over briefly. It's a function that will display whatever is in the parentheses on the screen, meaning the text interface that's being run, such as when you run your programs in Jupyter, or as we'll see later, if you run them from the command line. It can be very useful for seeing the value of something, whether x has the right value that we expect it to, or some wrong value, and that will help us to figure out why. It also can be very useful for interacting with users. And we will often use print functions, or inside of our functions, we will often use the print function to see what's going on or to provide some output to ourselves or to our users. So here's a little more on defining a function versus calling a function. We have this double it function that we're writing here. We take some x parameter and we multiply by 2, and then we're going to return that result there. We'll dig more into returning in a moment. So you see that we're using the parameter x that was given to us. And the challenge that we have here is if we think of functions as some sort of recipe or a set of instructions, you can't follow the recipe to create the cake or the cookies or whatever you are making with that recipe until you have the recipe. But once you have it, you don't have to give the whole recipe again. Once you've learned how to bake that item, you can just follow those steps again and again and again as many times as you'd like to. And the same is true here. We have to define what double it is, and then we're able to call double it with lots of different parameter values here. Positive value, negative value, decimal value, and so on. One thing that you really want to avoid doing is changing the parameter inside the function. So here we've taken in x, but then we said x equals 12.5. So that means that by the time I hit this line, no matter what x I was given as a parameter, I'm going to replace it and use 12.5 instead. Sometimes this looks like it works if you only test it with the value that you hard-coded here, that you wrote here as 12.5. For instance, I call double it with 12.5. Well, guess what? It works because x is then replaced with another copy of 12.5, and then I do 12.5 times 2, and then I print out the result, and it looks beautiful. And many programmers will do this and run it once and think their job is done. But because we replaced the parameter value, if instead I called double it with 5, then 5 will get replaced with 12.5, and then it will do 12.5 times 2, and it will print out 25 instead of 10. So this is a problem. It's usually best just not to mess with your parameters. Don't give them new values or things like that. Create a new variable if you need a new variable. Fine, just like we did for y here. We created a new variable. That's okay, but it's usually a bad idea to replace your parameters. Many beginning programmers try to do this because they want to be sure of what x is going to be. But in fact, the beauty of the function is we don't have to be sure of what x is going to be to know that I want to do x times 2. And so you have to overcome that uncertainty and work with it and use the parameter as if it already has a value, not write in for it to have some one specific value. We also cannot provide a value like 12.5 instead of the variable name. Sometimes programmers try to do that in the beginning as they're learning these things because, again, you want to be sure what the value is. Well, you're going to provide that value when you call the function, not when you define the function. We will see at later points that you can define default values for some of your variables, but that's for a future situation. Similarly, I can't just say x inside of the parentheses here when I call to double it, because then I haven't said what x's actual value should be to be multiplied by 2. So when I call, I must know what the value is that I actually want to double, and therefore I need to provide that here. I can use a variable name, but it has to be a variable that is defined. So if I said a equals 12.5, and then I said double it a, that's okay. But what you can't do is you can't just give back the same name as the parameter here and assume that the program is going to figure out that you mean 12.5 or whatever. It can't read your mind. And some of these may seem simple to you, but they are quite often ones that beginning programmers run into, and that sometimes some of us make mistakes on just without thinking. I have certainly done this one before, where I remember the name of the variable is x, and so I just pop an x in there, and I forget that I should have actually used a real value instead. Another pair of concepts that beginning programmers often mistake, and even advanced programmers sometimes swap accidentally, are printing some value inside of a function versus outputting or returning that value. So if you think about a mathematical function, like an f of x kind of function, it has a result. It has an output. If I feed in 5, I might get 10 out, for example, depending on what that function is. So when we're talking about a result from a function, that is an output, or that is what is returned. And we'll dig deeper into how you do those returns. But I just want you to understand that a function can have a result. It can have an output. It also, in a Python program, can print some information to make it appear on the screen. And in Jupyter in particular, these can get a little confusing because Jupyter will display to you the output from a function running, or even from a mathematical statement like 7.7 or 7 plus 7, but it will also display what is printed, and the difference is a little subtle. So if I did some operation like addition, or if I called some function and it had a result, like 14 here is the result of doing 7 plus 7, then it will display output as the label for it, and then the number 14. If I say to print 7 plus 7, 14 is still the result of that 7 plus 7. That is fed into the print function here, and then it is shown to you without that little out label on it. So this is a bit subtle, but pay attention to them. Because often we want to use the result of one function to do something else with it. So let's take a look at this here. Our doublet function previously was just printing the doubled version of whatever number was passed into it. The issue with that is it's shown on the screen and then it goes away. And we're not able to do anything with the stuff that's shown on the screen. Our users might learn something from it, and we might learn something from it, but we're not able to say, add 5 to it after that. After the function finishes, everything inside of the function, every variable, goes away. What does not go away is the result of the function, or the return value. So in Python, there's this special keyword, return, and it tells your function, you are done, give as your result whatever follows the word return. So if you gave me the number 5 to my doublet here, it would do 2 times 5, give me 10, and then it would return that as a result. So we can see here that I'm now able to do doublet with the value 2, that would give me 4 as a result, and then add 6 to it. Whereas my version before that just printed had no result. It did not return a result, and so we would not have been able to add 6 to that result there. We can't do further math or operations on it. In fact, here, we've even called doublet on the result of doublet. So this would take 3 and double, giving us 6. And then it would take that 6 as a result and double, giving us 12. This is a little more complex use of our doublet function, but hopefully you get the idea that I can take the result from a function and I can even feed it into other functions, like the print function or like the doublet function here. I also can store the result. And again, what's printed, I can't store in that way. I can't say x equals print 5. That does not work because print just shows it on the screen. But I can say x equals double it 8, and I would get 16 stored as x. And similarly, I could feed the result of calling double it into a print statement. So this allows us to have something that survives after the function is done executing. Whereas before I told you that the variables inside the function and all of those names and statements, they kind of go away at the end of the function. But returning allows us to have something that carries on after the function is finished executing. So to summarize, a function can take as many parameters as you'd like. We could, in our previous one, we gave it n or x or things like that. We saw one example that had 2 parameters. You can add as many parameters as you would like. You try typically to keep the number of parameters a little bit low. If someone has to keep track of 10 parameters, for example, they're going to get confused. They might put them in the wrong order. There might be confusion on your end while you're programming it of which variable is supposed to be which thing. And you probably should arrange things a little bit differently if you find that you're needing that many parameters. And we'll see some good ways to rearrange data in the future that would allow us to reduce the number of parameters that have to come into a function like that. But in general, you can give them as many parameters as you'd like. You separate them by comma and space, and you have a new spot for a parameter there. A function could return nothing, like our examples that just printed, or they could return something. When they can return only one result in Python. This may differ in other languages, and we'll see that our one result can actually be pretty big and complicated things in the long run, but a function can return one result. Maybe a very big number, maybe a very long string, or maybe a list of things, and we'll get into lists later, but one result. And a function, in theory, should do one logical task. No one is going to hold you to this rule. Python will hold you to the rule that a function can return one thing, but no one is going to enforce the rule that your function should do one logical task. This is a rule and a guideline for writing functions that are usable and that are modular is a word that often is used for this, that they can be sort of plugged in and it makes sense to plug them somewhere. The print function should not also establish a network connection and send a message to that network connection. Its job is to print. The double it function should not also get the square root of a number and print that out. It should double the number that was fed into it. This is also called abstraction. We abstract some set of behavior to mean one thing. What that one thing is up to you to design or up to you to follow a specification for. But it's often the case that programmers who want to group behavior together just sort of grab chunks of code and stick them together as a function. And while that will work, and you'll be allowed to do it, it gets very complicated when you have a function that does 2 jobs, for example, and you find a case where you really only need it to do one of those jobs. And so unless you can logically reason that what's being done in there is one task that you might instruct somebody to do, sweep the floor, that's one logical task. It takes many steps, but it's one logical task. If it's not going to fit one logical task in your abstract reasoning about it, then you should split it up. You should make sure that it does one job and does it well. So to summarize, what we saw was that we can group chunks of behavior. We can group lines of code together into functions. This teaches Python how to do a new thing. And if we want to ask Python to do that new thing, we use the name that we gave it, the name of the function. And we may just provide parentheses if that function does not take any parameters, or we might provide within those parentheses some values to be assigned to those parameters. This can get a bit tricky because of the fact that we're using variable names. Those parameters are a type of variable, and we don't yet know what their value is that someone's going to give to us. And so we have to think the logic through so that this function does its one job, its one logical task, using the range of possible inputs that might be provided to it by those parameters. And it either can return a result or do some task like printing output to the screen. And when it returns a result, we can take those results and do more with them, such as use them in later math or print them out at some later point or store them to be used or printed at some later point. And so all of these are different ways that we can put together functions and avoid our code having too much repetition, write very solid functions that we know do not have errors in them, and then reuse them in a variety, possibly an infinite number of ways.